Hello, in this video we're going to go over the first two questions in our examples. Maybe number 3 if we can get to it. So, number 1, let f be a function such that f of x equals 2x minus 4 is defined on the domain 2 is less than or equal to x is less than or equal to 6. The range of this function is. Okay, so two words are standing out to me. We have our domain and we have our range. Remember, we talked about our domain being our x values or our inputs and our range being our y values. Okay, so what I like to do is create a table. We notice here, this basically is saying x has to go from 2 to 6. So when I make a table, I'm going to start with the x value of 2 and go all the way to 6. Okay, anytime we have f of x, b of x, anything of x, remember that's just like y equals. We can use our y equals button to put it into our calculator. All right, and now we're going to try to find what is the range of this function. Okay, so I'm going to do 2x minus 4. And I'm going to go right to the table, and I want to look at these x values. So I see here at positive 2, we have 0. Whoopsie. The 3 is 2, the 4 is 4, the 5 is 6, and the 6 is 8. So I'm going to write all of those down. 2, 4, 6, 8. All right. So hopefully you can see here our y values, 0 to 8. And I see that in choice number 1. All right, question 2 says the domain of the function f of x equals x squared plus x minus 12 is. Domain, are we looking for the x values or the y values? Okay, hopefully you remember that that's the x. One of the little tricks, D comes before R in the alphabet, and so X comes before Y. So I don't know if that helps you. But again, we have this f of x, ding, ding, ding. Hopefully you're thinking y equals in your head, okay? Go to y equals, and we're going to type in x squared plus x minus 12. All right, first let's take a quick look at the picture of this graph. We're trying to find the domain, the x values. I might even try to bring this over. Does it let me? Yay! Okay, I'm going to make it a little bit smaller. Oops, that wasn't good because it cut off the bottom. Oh yeah, it cut off the bottom here. Oh well, I guess it was already like that. I'm sorry, I don't know why well, we can still use it. The other thing we can do is we can take a look at the table. Okay, and as I do with any quadratic, I try to find the symmetry. So I can tell that the vertex of this kind of looks like it might have been negative, and I'm noticing that here. Well, I can see here the lowest number is negative 12. We don't actually have the vertex here, but I'm going to bring the table over as well. Okay, so here's our table. Now, we want to know the x values. I guess I didn't really need to do all of this work, but it's kind of a good thing to look at. So the x values, this is our x-axis, right? So we are trying to think about how far to the left is this graph going to go? Well, hopefully you remember that even though we don't see it, that really keeps on going, right? And so does this side. It really keeps on going. So that's really going to keep on going forever. And you remember we call that infinity. So we didn't really need to know these, but if we would have needed to know the range, using this table and looking at your y values would be helpful. It definitely is more helpful if we have our vertex in there, which I don't see that here because it's not a whole number, but we know it's gonna, this graph is gonna keep extending forever in both directions. Okay, so we use this we would choose choice 2. This means negative infinity to infinity. And you want to always make sure you use the open brackets or parentheses. These mean open versus this closed bracket. That would mean to include that -4. But we can never include infinity because it's not really a number. It's just a symbol to mean that it goes on forever.